Australia spent 185 million US dollars on this dam, expecting it to last a century. Less than 20 years later, it began to fail, cracks appearing in the concrete and over 60,000 people downstream suddenly at risk. The solution? Build the dam again, but this time it will cost 3 billion US dollars. This is the story of why Australia is building the same dam twice. To really understand the scale of this failure, you have to understand how important the Paradise Dam was meant to be. Roughly 80 kilometres or 49 miles inland from Bundaberg in Queensland, the dam sits on the Burnett River, feeding an agricultural region built on high-value crops like cane and macadamias. Those farms live or die on a reliable water supply. This is also a region defined by extremes, long, harsh droughts broken by sudden, destructive floods. In that context, Paradise Dam was never just a convenience. It was supposed to be the backbone of the region's water security and a line of defense during the worst storms. Engineers designed it as a roller-compacted concrete gravity dam, a gigantic wall that holds back water through sheer mass. Paradise stretches nearly 600 meters, or about 1,970 feet, across the valley and can store around 300 gigaliters of water, enough to completely transform the Bundaberg region's economic future. But the wall doesn't just store water. It stands above more than 60,000 people living downstream. Their safety depends on this concrete structure riding out the worst flood the Burnett can throw at it. That's why its failure hits so hard. Taxpayers, farmers, and downstream communities have all been left dealing with the consequences of a dam that never lived up to its promise. So how did things go so wrong? Like many large projects, it started with two powerful drivers: speed and cost. The team chose roller compacted concrete, or RCC. Instead of pouring wet concrete in large blocks, RCC uses a much drier mix, closer to damp soil than slurry. Crews spread it out in long, flat layers called lifts, then compact it with massive vibrating rollers. In simple terms, it's like building a dam the way you'd build a road. On paper, it looks great. RCC is quicker to place, uses less cement, and can be cheaper overall. For Australia's first major RCC gravity dam, a $250 million budget looked efficient rather than excessive. But those fast and cheap advantages came with decisions that would haunt the project. First, the aggregate. The basalt rock taken from the riverbed contained too much clay and was chemically reactive. Second, the mix itself. On site, the team changed to a leaner concrete recipe with less cement and less fly ash. That saved money, but weakened the long-term strength of the dam. Critically, this change wasn't properly reviewed or tested. Compared with more than 900 RCC dams worldwide, Paradise ended up in roughly the lowest first percentile for cement content. Third, the construction technique. Those horizontal RCC lifts didn't bond properly, leaving weak, leaky joints running through the structure. And finally, the spillway and apron. The parts designed to safely pass major floods weren't built robustly enough to withstand the full force of the river. Taken together, this wasn't bad luck. These were conscious design and construction choices that prioritized speed and savings over long-term resilience. In early 2013, Paradise Dam faced its first real test: record-breaking floods. As water surged over the crest, the dam's weaknesses were exposed. The already underbuilt spillway and apron were hammered. The concrete slab at the base broke apart, and floodwater began eroding the rock beneath it. If that erosion had cut much deeper, the results downstream could have been catastrophic. The government rushed in with about 23 million Australian dollars for emergency repairs, patching the apron and stabilising the structure. Publicly, they reassured locals that the dam was safe. Privately, engineers were becoming more and more concerned. They knew the dam had barely survived this event and might not live through the next, larger one. By 2019 and 2020, the warnings were too loud to ignore. A new detailed risk review was ordered. Experts concluded that the dam no longer met modern safety standards. Under a probable maximum flood, the worst-case scenario designers planned for, the chances of a failure were unacceptably high. In response, operators lowered the reservoir to reduce pressure on the wall. Then, in a dramatic move, crews literally cut 5.6 meters, around 18 feet, off the top of the dam. Overnight, the structure that had been built to secure the region's water was officially no longer trusted at its original height. That decision reduced the reservoir's capacity by roughly 40 to 57%. For Bundaberg's farmers, many of whom had invested millions on the promise of secure water, it was devastating. So why not just fix it properly? Raise the wall again, strengthen the spillway, and move on. The uncomfortable truth is that you can patch parts of a dam, but you can't easily fix the entire structure when the concrete itself is the problem. Deeper investigations gave engineers a forensic picture of what was happening inside the wall, and it was worse than anyone expected. The spillway and apron were serious concerns, but the real danger lay in the RCC itself, the lean, low cement mix, and the way it had been placed. Testing showed the concrete was porous and far more vulnerable to weathering than it should have been. The weak bonding between those RCC lifts wasn't a localized issue. It ran through the dam. In effect, the wall had built-in leak paths, channels where water could travel through the structure and gradually wash out cement. Engineers call this leaching, and once it starts, it's incredibly hard to stop. Then came the real turning point. Lab aging tests revealed that the clay-rich aggregate, combined with low cement content, was causing the concrete to expand and contract more than expected. That subtle movement was slowly tearing the structure apart from within. Strength wasn't just lower than planned, it was declining faster than any dam of this age should experience. At that point, the verdict became clear. You can rebuild a spillway, add drains, or reinforce weak spots, but you can't confidently restore a wall made from concrete that is weak, permeable, and actively deteriorating. Even if engineers restored the dam to its original height, the underlying risks would remain. Every major flood would once again put tens of thousands of people in a firing line. In the end, building a completely new wall was the only reasonable option. Trying to save the original Paradise Dam would have been a gamble with people's lives. By 2024, the government finally drew a line under the old structure. Repairs were stopped and a new plan was approved. Build an entirely new dam about 90 meters downstream. The price tag for that replacement? Roughly $3 billion. That's how Paradise Dam earned its place in a series about projects we're having to build twice. Instead of demolishing the old wall immediately, it's being turned into a temporary cofferdam. It will hold back the river while crews excavate the valley below and build the new permanent structure in the dry. This time, the design is meant to address every flaw in the original. The concrete mix will have a much higher cement content, with strict quality control to make sure each lift bonds properly. The new spillway and stilling basin will be larger and more robust, designed to handle modern estimates of extreme floods and rapid discharges, the very conditions that nearly destroyed the first dam in 2013. The project also assumes a future of bigger and more frequent floods, rather than treating them as distant outliers. Safety margins are higher, and there's more instrumentation built into the structure, sensors to track stress, movement, and temperature over time. Environmental performance is being taken more seriously as well. The design must better protect habitats for species like the Queensland lungfish and several turtle species, considerations that were largely neglected the first time around. When you add it all together, the original $240 million Australian dollar build, the emergency works, the risk reduction measures, and the full replacement, the cost of getting Paradise right runs into the billions. Building a second dam immediately downstream of a compromised one is a delicate multi-year operation. There isn't much room for error. It typically unfolds in 4 main stages. First comes preparation. Roads are upgraded, temporary camps are set up, and utilities are relocated. Geotechnical teams drill into the riverbed and valley walls to map the bedrock and identify any weak zones. The new dam needs a solid foundation. Next is excavation. Crews dig down to competent rock, removing weathered material. Once they reach reliable bedrock, they inject grout into cracks and fractures to prevent water from seeping underneath the future dam. With the foundation sealed, construction of the new wall can begin. RCC is placed in thin layers with much stricter controls, creating a more monolithic structure with stronger bonding between lifts. Larger spillway gates are built in, along with monitoring galleries and embedded sensors that will watch the dam's behavior for decades. Finally, during commissioning, control of the river gradually shifts to the new structure. The reservoir is filled in stages, while engineers watch the dam closely for any unexpected movement. Only once the new wall is fully operational will the original Paradise Dam be partially demolished and left as a passive element in the river system. This downstream replacement model isn't unique. Switzerland's Spittelam Dam, for example, followed a similar approach. The difference is that Spittelam was replaced after around a century of service. Paradise Dam is being rebuilt less than 25 years after it opened. So what does Paradise Dam tell us about big infrastructure? At its heart, this is a story about the hidden cost of cutting corners. Using cheaper materials, weakening mixes, easing off on quality control and rushing construction can make a project look efficient in the short term. In the early 2000s, those choices helped create a financial disaster. A dam that was meant to last a century but became one of Australia's most expensive infrastructure failures in under 20 years. It also shows how our understanding of risk and climate is shifting. Designs once considered acceptable for a 1 in 200 year flood now look dangerously optimistic as extreme weather becomes more frequent and more intense. Globally, we're seeing the same pattern. Bridges need total replacement sooner than expected. Tunnels leak or crack. Major projects have to be rebuilt or heavily retrofitted because they were never truly designed or constructed for the world we're actually living in. Paradise Dam sits at that intersection. A fast, cheap solution that turned into a long, expensive and disruptive rebuild. Paradise Dam's replacement shows what's at stake when a project built to save money ends up costing far more in the long run. It raises a bigger question for every country facing new extremes. Can we ever truly balance speed, efficiency and cost when building dams that protect entire communities? Share your thoughts below and don't forget to subscribe for more Megabuild stories. See you in the next one.